Hello everyone. In this video we're going to talk about solving quadratic equations. We're going to focus on a couple of different methods here, graphing and factoring. So first thing I just want to discuss is the difference between a quadratic function, which is what we have been looking at, and a quadratic equation. So a quadratic equation is slightly different from a quadratic function in its form and also in what we can do with it. So quadratic functions that we've been looking at, these are generally two variables. They are a relationship, a relation that exists usually between x and y. So we can have something like y equals x squared plus 2x plus 1, for example. This would be a function, and this particular function would look something like this. It's in two dimensions. That's important. We can have different forms, obviously. We can have a form like y equals -3 times x plus 7 to the power of 2 minus 4. That would be an example. We could have it in factored form, so 2x plus 1 times x minus 8, for example. So these would all be functions. They're two-dimensional. They define a set of points that we can represent graphically as a parabola. So in other words, there are infinitely many solutions to these equations. They are equations. They have an equal sign in them. But it doesn't make sense to talk about solving that equation. So we wouldn't ask you to solve the equation y equals x squared plus 2x plus 1 because there are infinitely many solutions. Every single point on that parabola is a solution. An equation, on the other hand, generally when we're talking about solving a quadratic equation, we're talking about something that has one variable. Now again, technically these functions are equations, but just the way we're going to use it in this unit, solve a quadratic equation, it's going to have one variable. So something like, for example, x squared minus 9 equals 0. That is a quadratic equation that we can actually now solve. This isn't defining an infinite number of points in two-dimensional space. This is setting up a relationship that exists for a single variable. And in this case, we have two possible solutions here. X could be positive or -3, and this equation would be true. So we can talk about solving equations. The equations may have no solutions. So in other words, there might be no variable that makes it true. For example, x squared equals -5. There is no number we can square, no real number we can square to get -5. So this has no real solutions. So it is possible to have no solutions. It's also possible for quadratic equations to have one or two solutions. So we'll talk about those different scenarios as we go through the unit. So now let's start with an example. We're going to just look at the quadratic equation, x squared plus 5x equals 6. So this is not a function. There's no y in there. It's only one variable. But you'll notice that I have graphs, and that's because we can actually use related functions in order to solve the equation. We're also going to look at solving this same equation algebraically, so that we will get to in a moment. But for now, just discussing graphically how this might work. There's two different graphs here because I can sort of approach this in two different ways. One would be I can consider that there are two functions that are related to this equation. The left-hand side of the equation can be one function, so the first function, y1 equals x squared plus 5x. And the second function, just y2 equals 6. So that's this horizontal line, y equals 6. And then the parabola that's drawn here is y equals x squared plus 5x. So I've got two different functions. So essentially, I turn this single equation into a system of equations. Now, I'm not interested at all in the value of y. I know actually, because one of the equations is very simply y equals 6. I know that the value of y is 6 for solutions to this system. But I don't care about that because y is a variable that I've introduced to solve this. What I really care about is the values of x. But like we learned when we were solving systems of equations in a previous course, the solution graphically to the system is the points where the two functions intersect. So each of these points that I've drawn on here in green represents a solution. Now you can find that using your graphing calculator, or in this case, because they are grid points, they are lattice points, I can see that this is the point 1, 6, and I also have the point -6, 6. Now again, the y value is not interesting to me at all because y is a variable I introduced, but the fact that x equals -6 or 1 is the solution. In fact, if I were to plug these values into the original equation, so negative 6 squared plus 5 times negative 6, I would get 36 minus 30, which is in fact 6. Or if I did 1 squared plus 5 times 1, well, 1 plus 5, that is also 6. So I can see that these two x values do satisfy that equation. And I can tell from the graph that there are no other x values that would satisfy the equation. Now, the other graph that's drawn here is an alternate way of dealing with this. And that would be if I started out by saying, okay, well, I'm only going to deal with one function. I'm going to rearrange this so that I'm solving the equation x squared plus 5x minus 6 equals 0. So put everything over onto one side and have it equal to 0. Then I only have to deal with one function. Technically, I'm kind of dealing with two. So the parabola that's drawn here is y equals x squared plus 5x minus 6. Where that is equal to 0 is at the x-intercepts. So in this case, the x-intercepts, or in other words, where y equals 0, well, I have 1, 0, and I have negative 6, 0. So graphically, my graph doesn't look exactly the same, but I do find the same two x values. But because I've rearranged the equation a little, the y value in this case equals 0, but I don't actually care about the y value, just like in the previous case. The y value is something I've introduced. Y isn't actually part of the equation to begin with, so my solutions are negative 6 and 1, as we found in the other graph. Either one of these methods would work. It just depends on whether you're wanting to graph one function or two. And if you're putting it in your graphing calculator, it really is kind of irrelevant. Now, to solve algebraically, there's a few different techniques, but the easiest is, if it is factorable, the easiest thing to do is to factor it. But what we need to do in that case is we need to have it equal to 0, because solving by factoring makes use of the fact that the only way to achieve a product of 0 is if one of the two components or we can have more than two components, but if one of the components is 0, then the product will be 0. Well, factoring allows us to express this polynomial as a product. In this case, the two factors would be x plus 6 and x minus 1. And so either x plus 6 equals 0, which means x equals negative 6. No surprise there, we already know the solutions to this equation. Or x minus 1 equals 0, which means x equals 1. So same two solutions, x equals negative 6 and 1. I've already checked those solutions, so we definitely know they work. But that would be the algebraic solution if it is factorable. If it is not factorable, we will explore that in a later video.